So, good afternoon, everyone, and welcome. We will give a couple more minutes waiting for people to join. Okay, we will wait one more minute before starting. I see now 15 attendees. We are waiting for 32 people. Okay, I think we have enough time now. So welcome everyone. This is a webinar from the Sustainable Nano series of seminars from the Spanish Network State and Sustainable Technologies. So we will have the Verónica from University Coruña, and then I will give an overview of our work at ICN2. Then I will leave you with Verónica. Verónica, thank you. So I will stop now and you can start share screen.
Okay, good afternoon. Thank you for joining this webinar and for inviting me to be a speaker here. I will share my screen. Okay, can you see my screen, right? Yes.
Yes, from my side. And just remembering the attendees, you can make questions on the Q&A session or in the chat, and we'll try to answer them.
Okay. Well, I am associate professor at the University of Coruña. My PhD was in computer science, but specialized in artificial intelligence. So this is my topic of research. In particular, I've been researching on a lot of years on feature selection methods. Well, I will explain later, but feature selection methods try to determine the relevant information for making a decision in machine learning models. And in the last few years, I was interested in green algorithms or green artificial intelligence, which in essence is making AI more efficient and more sustainable. And today we will talk about this topic. So I would like to start by asking you a question, even when I don't expect you to answer, just answer in your heads, right? But what effect do you think that AI systems have on the environment? Positive, negative, or neutral? So just take a moment to think about this. And this question is not mine, actually. This question is part of a survey conducted between March and July 2021 by the European Commission. And at that point, 63% answered that AI is a harmless agent for the natural environment. 32% stated the positivity of their use, and only 5% defended the negative effects that AI could have on the environment. Well, I don't know what you have thought about this, but I make this question a lot of times. And nowadays, the results are very different. And most people answer that is negative. Some people answer that is positive, and almost nobody answered that is neutral. So in only a few years, this opinion about AI and its relationship with the environment has changed a lot. And actually, as we will see in this talk, this was a tricky question, because the real answer is that AI can be both positive and negative for the environment. Well, as you may know, in the last few years, we have seen a revolution with AI and machine learning, and we have a lot of sectors that use nowadays artificial intelligence, healthcare, finance, transportation, education, well, almost everything you can think of. And to achieve these very good results that we have nowadays, the machine learning models had to be more complex. This translates usually in a larger number of parameters to estimate in bigger models, as we have seen with the LLMs, etc. And this has associated a high energy consumption. This revolution about artificial intelligence has some ethical aspects that we have to consider. And here I say past and present, but when I say past, is like before ChatGPT or something like that. But some years ago, for example, in 2019, we had some recommendations for the European Union, some guidelines to have a trustworthy artificial intelligence, and there were several requirements, but we can think of 3 of them as the most important ones in the community. So for some years, we have been very worried about these 3 ethical aspects, which are the presence of bias in some algorithms and the fairness of their results. Well, this is a very complex subject. Actually, I could spend 1 hour talking about this. I mean, it deserves a specific talk about this. But to sum up, we still have artificial intelligence systems that have bias, because bias is in the data. Our systems learn on this data, and these bias are propagated. And we were also very worried about the respect for privacy of our data. And also transparency is very important, because as you might know, the machine learning models that work best, which is deep learning models, are not explainable. We don't know how they make some decisions, so they are not transparent. And in some cases, this can be a problem. So these were like the ethical concerns that we have had at the beginning. But now, since we have ChatGPT and the LLMs, we have new ethical concerns. For example, maybe some chatbots are manipulative and can manipulate, I don't know, older people or something like that. There is always this potential problem of loss of jobs. I won't get into details here, but well, it seems obvious that some kind of transformation in the job market will happen. There are a lot of problems of misinformation. because nowadays with generative AI, we can generate images, videos, audios. So it's really difficult to know when some news are real and when they are fake. So it's very important to check on the sources and double check everything. And there is a new concern nowadays, which is the sustainability of these AI systems and algorithms. But the first time that I was aware of this problem was in 2019. And I read a paper that estimated the carbon emissions of the training process of a language model called BERT. And the paper said that training this AI model could emit as much carbon as 5 cars in their lifetimes. So it was the first time that I was aware of this, because, of course, I've been researching on AI for a lot of years, and I knew that when you are doing some experiments, you have to wait for weeks or months in computers that get really warm, and you need air condition and these kind of things. But I never thought that AI could have this effect on the environment. With ChatGPT, this was like more obvious. And although we don't know exact data about this because OpenAI is not so open, we have some estimations. And for example, researchers from the University of Copenhagen, I think, estimated that the training, well, when I say training, if you don't know the term, is when the AI algorithms learn how to do something, this part that we have before they are used to predict something new or to generate something new. So, well, the estimation was that one session of training of GPT-3 required the amount of energy equivalent to the yearly consumption of 126 Danish homes. So, you know, this is a lot. And this was only on the training part, but we have the inference part, which is when we generate or we work with this AI model to predict or to produce new results, and also has a very significant energy consumption. In fact, with the recent advancements in AI, now we have some kind of concern about, do we have enough energy for all of this? And we have seen several news about this. And for example, the Trump administration with the Stargate project was kind of there was kind of a concern about, do they have enough energy for this? And it's expected that this energy consumption related with all the AI ecosystem will grow in the next few years. And well, I was mentioning that first, the estimations of energy consumption were focused on the part of training. At the beginning of this green AI thing, researchers were focused on the training part, because the training part, as I said, can last for months. But nowadays, with the increasing number of users of this kind of technologies, we are also worried about this inference phase. And for example, this is a very interesting paper in which the authors compare the carbon emissions of different tasks related with generative AI. And for example, they conclude that generating images consumes much more carbon, or emits much more carbon to generating text and this kind of thing. So in general, the take-home lesson here is that generating images or working with images in terms of damaging the environment is much worse than just generating text. Actually, we have seen an example of this with some weeks ago with this trend about generating Studio Ghibli images. And this was like crazy. Actually, Sam Altman, the CEO of OpenAI, said that they added 1 million users in the last hour, which is crazy. And he said their GPUs were melting, and they have to put limits on this because, well, as I said, generating images is the most costly operation in terms of energy consumption, also money, but well, energy consumption. So they had to stop this. So I don't know, sometimes for me, when I see this kind of viral trending things, it's very sad because most people are not aware of the impact of this kind of things. So well, myself, I try to not generate images when there are these kind of trends. And also something that is that is funny. You know that there is this meme that is like, oh, I always say please and thank you to ChatGPT because when in some years these robots come, I don't know, to conquer the world, they will say, oh, this one was very polite, so we won't kill him or her, right? But this little thing that we don't think about it, you know, like saying you ask something to ChatGPT answers, and then maybe you say, okay, thank you. This little thing has an energy cost because you are sending another query and ChatGPT has to answer again. So, well, Sam Altman speaks in terms of dollars, millions of dollars. He said that they are spending tens of millions of dollars with this little thing. But of course, these millions of dollars are also related to energy consumption. So think it twice before saying thank you to ChatGPT. And there is this problem related with, I mean, AI is like the software, but it needs some hardware. And for the hardware part, these kind of models are typically run and trained on data centers. And the data centers, of course, consume the energy, but they also need some water to refrigerate because they are very warm. And we have seen some cases in which these data centers are placed in dry areas. So I don't know, this is not ethical for me. And we have seen in Spain, I think that Meta wanted to build a data center in Talavera de la Reina or something like that, which is already a dry area. So this is not good for the environment. And we have some estimations also of the water that these models consume, and they are estimations, but just that you can be aware of this. For example, a recent study showed that GPT-4 uses 519 milliliters of water to generate 100 words. And with the lot of active users that this kind of systems have. So this is a lot of water. And if you check on this study, you can see a lot of examples to visualize this consumption. It is really interesting. And this thing with data centers is, well, it's tricky because I was in some event talking about AI, data centers, etc. And I knew that there is a European project with a partner in Spain, and they are studying the possibility of sending data centers to space, which I don't know. To me, it sounds like science fiction or something like that. But they said that, of course, they have a lot of energy from the sun, and they don't need to refrigerate because of the temperature of the space, but they have a lot of other problems. But just as you know that these kind of things are being studied. And we have more other problems related with this generative AI, such as that, for example, there is a problem with e-waste. So after all this bad data, I mean, I don't want you to be sad about this, but just to be aware. But we have green artificial intelligence. And what is green artificial intelligence is the AI research that tries to produce novel results, but taking also into account the computational cost and ideally trying to reduce the resource consumed. And this is in contrast with red AI, which is the traditional AI research, that its objective is just to improve the accuracy of the models, and actually through the use of massive computational resources regardless of the cost, something that we have seen in the first months of the ChatGPT revolution. It was all about scaling. Okay, so let's use more data, more GPUs, and let's increase the results. But recently, we have seen another trend because, for example, DeepSeek, it's something more related to green AI because they were able to produce similar results than with ChatGPT, but they require less computational resources. So it's this kind of things. And there is this another related term, which is green algorithms. And there is a twofold contribution. First is green buy, and green buy is when you apply AI algorithms to areas and sectors that contribute to sustainability and to combat the climate change. So it's, okay, I use AI algorithms, maybe they are efficient, maybe they are not, but I apply them to try to solve problems related with the environment. And then there is greening, which is try to develop more efficient algorithms. So, for example, to study green buy, which is the application of AI to problems related to the environment, I like this paper because they analyze all the SDGs, in particular the targets within each SDG. And there are very interesting things, like, for example, AI can be both enabler and inhibitor of some targets. And in some cases, it's good, or it's bad, or it's both. So this is related to the first question that I asked in this talk, which was, is it good or is it bad for the environment? And I said, well, the real answer is that it can be both, like we can see in this paper. And well, I will mention quickly some areas in which AI is applied and that can be considered green buy, for example, in water management, for predictive maintenance of water infrastructure, for monitoring and predicting water demand, for monitoring wastewater sources. In general, AI is good for monitoring things and predicting things. It's used a lot in smart agriculture, maybe through the use of AI robotics or precision monitoring, planning and management, I don't know, trying to decide the best moment to do something, etc. In energy, it's it's applied a lot to energy, for energy supply and demand prediction, energy efficiency in buildings, for example, etc. And also in the area of transport, of course, for autonomous vehicles, we need AI. And also for demand prediction, logistics planning, I mean, for example, to optimize the traffic lights in a city, depending on the traffic and things like that. And now we move to greening, which is the development of AI algorithms that are more efficient. And there are some ways to achieve this, and one of them is the algorithmic optimization, which in essence is making the algorithms more efficient. And there are different ways to achieve this. For example, through quantization, which is like to use less bits. For example, in the inference part, this is related with low precision arithmetic operations. I will talk about this later a little bit more, but it's like, for example, instead of using 64 bits for the operations or for storing data, which is the typical measure, trying to adapt the algorithms so they use only 8 or 16 bits, but if they are able to achieve the same results, you are making the algorithms more efficient. As I said before, AI is very related with the hardware. So there is the possibility to choose more computationally efficient hardware. We have seen in the last years an increase in the use of more efficient GPUs. So in this graph in the left, we can see the efficiency improvement of these chips. And in the right part, we can see a graph in which we can see what happens when we increase the number of cores because we are parallelizing a process. And of course, when you increase the number of cores, you are able to reduce the training time, but after some point, this reduction is marginal. And what happens is that at some point, you are the carbon footprint is raising because you have a lot of cores. So this is worse for the environment, and we have to take account of these kind of things and to use more efficient hardware. And also related with this is a sub-area of machine learning, which is edge computing, which tries to train the models on the edge devices instead of transferring all the data to the cloud or to the data centers, etc. There is also another important thing, which is the choice of data center, because at the end of the day, the carbon footprint is related to the location of the data center and how electricity is produced in that country. So, for example, in this graph, we can see that different European countries have a different greenhouse gas emission intensity of the electricity generation. So maybe we should choose data centers in countries in which it's more efficient to generate electricity. And well, another way is reducing the pragmatic scaling factor. Machine learning algorithms, when they are trained, they are executed several times. And sometimes it's like another round of training, just to improve, I don't know, 0.01 or something like that. So I think that it's not the same if you are trying to obtain a cure for cancer, that you have to put all the resources. But if you are just trying to, I don't know, recommend a movie on Netflix, maybe we can sacrifice a little bit of accuracy and reduce this time and make the algorithms more efficient. And we have several tools for calculating and more importantly, for predicting the energy consumption of machine learning algorithms, so we can have an idea about the energy impact of our algorithms, for example, carbon tracker, green algorithms, and we have more. And I find very interesting this thing of calculating this impact, because if light bulbs or our fridge, etc., things in our houses have these energy ratings, maybe artificial intelligence systems should have too, so people can be more aware of the energy consumption of these kind of systems. And to relate this with regulation, I said before, I mentioned these ethic guidelines for trustworthy AI released in 2019. And there were 7 specific requirements to have trustworthy AI. And one of them was societal and environmental well-being. So this relationship between AI and the environment was present some years ago, but the problem is that in most cases it's much like a recommendation and not an obligation. Actually, it also it's present in the AI Act. The Parliament's priorities to make sure that AI systems used in the European Union are safe, transparent, traceable, non-discriminatory, and environmentally friendly. But nowadays, up to my knowledge, this is only a recommendation. There are no specific taxes or things like that. And maybe you are asking yourselves, what can we do to solve this? But well, in this paper is very interesting. You can find some recommendations, but like the take-home lesson that I would like you to take home is that, for example, it's important to be aware of this problem. Try to reuse, especially with generated images. And also, if you have to use artificial intelligence models for your experiments or something like that, avoid to crack a nut with a sledgehammer, meaning that, for example, nowadays it seems that everything has to be solved with deep learning and LLMs, and there are simple tasks that can be solved with other classical machine learning models that are much more efficient. And just to finish, I will talk very briefly about 2 of my projects related with this. One of them is greening, which it finishes at the end of this month, so we are wrapping up everything, and it was green and fast feature selection algorithms. As I said, feature selection algorithms try to determine the relevant features for a problem, for predicting something. And we had 2 main lines of research. The first one was to develop new feature selection methods that work with reduced precision. Reduced precision is what I mentioned before, that using less than 64 bits. I will show you some results now. And also there was another line of high performance computing optimization. So trying to accelerate the feature selection process using these techniques and the recent advances in GPUs. This was what I was talking about. The typical format to store numbers, information in our computers is double precision floating point 64 bits. And we were trying to use, for example, fixed point 16 bits. And just the thing is that you have less precision in the numbers you use, but sometimes you don't need a lot of decimal parts. And here we can see the results when we are comparing the ranking of selected features with the version with 64 bits and the versions with 32, 16, 8, and 4 bits. And when the result is 1, it means that the rankings of relevant features are the same. So, for example, in most cases, with 16 bits, we had the exact same ranking. And even in the cases in which the rankings were different, we then applied a classifier to predict, and we obtained the same results. So we achieved good results in this line. And we also had this part about accelerating the feature selection methods, and we obtained very relevant accelerations. So we were able to reduce the computational time of these algorithms. And the other project that I have about this is the UDC Inditex chair of AI and green algorithms. And here we have 4 main lines of research. The first one is, let's call it greening, develop algorithms that are energy efficient. The second one is green by, applying AI for, in this case, energy efficiency and sustainable development. We have a research line of sustainable robotics. And the last one, which is very important and sometimes is overlooked, is the study of ethics, social, and economic implications of green algorithms. We have a multidisciplinary team covering all these lines. For example, as results of this project, we have this general review paper about green artificial intelligence. If you are curious about this topic, you can read it. And we have some algorithms, for example, for federated feature selection. Federated learning is what I said before, is when you train your algorithms on edge devices and you don't transfer the data. You only share with the other edge devices the parameters of the model. And in this way, besides of being more efficient, this respects the privacy of the data, because the data never leave the edge device. So this can be very useful for some scenarios in which privacy is a requirement. And this is it. If you scan this code, you could access kind of a citizen science project that we are performing on the chair on green artificial intelligence, and it's in Spanish. But if you could answer to those questions, it could be great, because we are trying to analyze what is the opinion of people about this topic. And that's it. If you have any question, I will be happy to answer.
Okay, you can write your questions in the chat or in the Q&A panel of Zoom, and we will try to address them. Okay. At the moment, I don't see any question. Maybe we can give just one more minute to give you the chance to think of a question. Okay, I just have one quick question. So, which one will be a recommendation for the users nowadays of these intensive large language models? Because yes, from the point of view of a single users, there is not too much to do, but which are small actions or they can do to sum for the impact of the environment on the use of AI?
Yeah, related to chatbots, which is what we use the most nowadays. Well, as I said, being very careful when generating images. Maybe we have some free image on these free banks of images that we can use. We don't need to generate new images for every new presentation, or oh, how do I look like a Disney princess? How do I look like a Studio Ghibli? These kind of things. I mean, they are fun, but they are very bad for the environment. And some things that can be, you can search them on Google, but now we ask everything to ChatGPT. And a query on ChatGPT consumes, I think, like 3 more times that a query on Google or something like that. So we use it when you feel that you need it, not just for fun. And well, just be aware of this.
Okay, thank you. So thank you, Veronica, for really nice presentation, and then we will move to the second part. So I will introduce briefly what we do at the Catalan Institute of Nanoscience. I will start sharing the screen. Okay. I think you can now see my screen. Is that right, Veronica? Okay.
Yeah, we cannot see the screen. Oh, sorry. Yes, yes,
Is
yes.
okay. Okay, so I present myself. I'm Andrés now. So I come from science, from physics. I did PhD and postdoc in computational physics, actually simulations. It's also a field where we think about the impact of the high performance computing in the environment. We use supercomputers, and then I moved to data science and machine learning, and then I started here at the Catalan Institute of Nanoscience and Nanotechnology. So within the 𝗧𝗹𝗸𝗶𝗽𝗁 grant program from the Spanish government, the Catalan Institute wanted to, let's say, provide some enabling research areas for the institute. So we are at the institute performing basic research at the level of nanoscience and nanotechnology. We have 19 research groups. Most of them are experimental research groups doing fabrication of devices, 2D materials, synthesis of organic and nanoparticles. And then we also have 2 theoretical groups on theory on the molecular level, quantum theory of the materials. Then the idea was one of the key enabling areas was artificial intelligence. So thanks to this 𝗧𝗹𝗸𝗶𝗽𝗁 grant, the institute created the artificial intelligence platform, and now we are a team of 2 persons, so myself and another machine learning engineer, Francisco Molina, that is with me. And what we want to do, our main goal is to give some support to all the researchers. So the long-term vision is that our platform will become a driving force for sustainability and impact in the way that the research is done. So basically, the main task we do is assist every experimentalist that need it and every researcher here at the Institute to implement machine learning solutions, from classical machine learning to some more advanced deep learning techniques or the latest large language model. And so basically we help them into implementing the algorithmic solution and also the design of the experiment and the design of the methodology of machine learning and AI by itself. We also are in charge of formation. We provide courses for the researchers, for them to be, let's say, more knowledgeable on the area of artificial intelligence and the use of machine learning for research. And then we also direct the strategy of the institute to make collaborations and see the impact of artificial intelligence. So so this is like the big overview. And then I want to share in the line of what we are doing here, of this green coding. I will share with you. Give me a moment. I think, let me see. I think it's this one. Okay. So this is a. Let me see if if I'm checking. Okay. So this is one of the tools that Veronica was mentioning. So we are using one of them in every project that we initiate here at the Institute. This one is called 𝐸𝐴𝐴𝐻. You can find it in GitHub. It belongs to the group of a group of people. I think they are from Data for Good community, and from another community called Mila, and they have developed a tool that you can implement in your code in order to track the energy intensity of the use of computer. Basically, what they are doing with this code is measuring the consumption of energy on your device, on your computer, for a given part of your code, or you can do it for the whole code, or the whole, let's say, monitor your whole consumption of your computer, and then translating this into carbon emission with an equivalent equation. So just to give you a brief example, this is as simple as using a decorator. A decorator is, let's say, an addition to a function that you can make in Python, and then you can define this decorator on top of any of your functions in your code. This means that, for instance, if we have a function that is training our neural network, our deep learning model, every time you have to train the model, this function is going to be called. And then with the decorator, what he's going to do is to start tracking the amount of energy consumption and the amount of equivalent carbon emission. Then you can do this, or you can also do a general context. That means inside your code, you can start from the code, from 𝐸𝐴𝐻. You can start this section of the code that is an emission tracker, and then this will make a track of everything that is inside this section of code. For instance, in this case is the compile and the fit, the training of your function. And then with this, what you can do, then basically I'm going to show you. So from the ICN2, what we are doing is we have generated now a GitHub where we are going to develop every project regarding machine learning. So I will show you, for instance, one of the examples we are working now. This is a project using deep learning to denoise images, spectra from Raman spectroscopy, for example. So this is not that important right now, but the important part is that we have created this tracking method inside our function, and every time we have to make an experiment in machine learning, that means we are doing an improvement of the algorithm. We are changing hyperparameters. We are seeing the performance with new data. So we track this. And with this, you can go to the 𝐸𝐴𝐻, and you make an account, and you link it to your code. And it allows you to have a tracking. So for instance, you can create an organization, and in organization, you can have all your different projects. So for instance, we have right now running 3 different projects using machine learning. And for instance, this one that I was showing you, this denoising of Raman, every time we run our code, we have a new tracking point in the tool with the equivalent of kilograms of CO2 emissions. And here, so for instance, we have made several different trainings for our model. You have to tune your parameters, find the best uh, combination of data and architecture of your model. And then at the end, it will give you the total consumption of your code. So this on the first side, it makes you aware of the consumption of the energy. That is a good first step. And as Veronica was mentioning as well, we are always aware of when to use and when not to use. So there are also many good practices in machine learning, and that involves creating a baseline, sometimes maybe a deterministic algorithm. So basically a decision or the knowledge that you have used before for selection, for instance, you need to predict what is the temperature tomorrow in Barcelona. So maybe just with a deterministic approach, saying, okay, if it is summer, it will be sunny. That is a deterministic approach. It's a rule that stays the same, and you don't need any probabilistic approach. Then maybe this solution is much better than a machine learning. So it's really important to think about that, the baseline of the performance of your goal in your machine learning before really implementing, and seeing if the trade-off between the accuracy of your model and the ability to predict is really important for your case study. In this case, for instance, we have seen this was a short project. We did it during 2 weeks, and we are doing a really small model. But for instance, we can already see that we have consumed the equivalent of 500 meters of car riding, for instance, or the 0.3% of the consumption of a weekly energy emission of a citizen in US. But this can really go up if you start training really heavy models like the large language models and so on. And then you can track as well the the impact on your whole organizations and so on. And then this is a tool that we are using. As I'm telling you, there are also many small things that you can do. One of them is following good software practices. It can seem unrelated, but when we are developing a code that can be reused, that you don't need to start from scratch, you don't need to uh, you can add to the state of your current development. This saves time and computing efforts. So usually in research is difficult, and everyone is working as they can with notebooks, with the separate scripts in Python or whatever, but following a structure of a code, using GitHub, making track of the version of your code, and measuring at the end the performance of your machine learning and comparing with some basic baseline is are these small practices that in the end are also important uh, to be aware of, using at least responsibly the computing that you have at hand. So this was basically the example I wanted to show you. Here they have the web page, their code Carbon, and for instance they have made some estimation on the consumption, as Veronica was mentioning, on different models. On these are natural language process models, the ones that came before ChatGPT, like BERT, and some of them are really consuming a lot of energy, in total as 26,000 kilograms of CO2. And this is comparable, for instance, some of these models are comparable to a yearly home energy consumption. And then this kind of tracking tools become important to be aware. I think for that, it will be now for us. Uh, Again, thank you to be here. Thank you, Veronica. And then if you have any more questions regarding this last section or the part of Veronica, if you have still some questions, so we are open now. Let me see. Okay. So I don't see any questions. I will share again the screen of the Sustainable Nano seminar. Okay. So if we have no questions for the moment, so we thank you everyone. We will stay here for a couple more minutes if someone has some question. I see no. I see an open question. Okay. Thank you. Okay, thank you, Pilar. She's just saying thank you. Very interested and clear. And from our side at the Catalan Institute of Nanoscience, so we are always open to have discussions regarding what we are doing in regards of using and applying machine learning for research. So you are always welcome to send us an email and we can discuss any interesting topic that you have in mind. Okay, if that is all for now, I think. So I again thank you, Verónica, for your presentation. Thank you for everyone for coming to this session. And then I think we will now end the session. And thank you for the SusNano for providing the support for these webinars. Okay, have a nice afternoon, everyone. Okay, goodbye.
Thank you.